might be. Alright, so we can go to 1.7, we can call it B, since Monday we called it A. And we're going to look at these combining functions. And then the second part is doing these things called composite function. So we're going to start off by doing some combining. And combining is just putting some things together, right? So we're either going to add functions, subtract functions, multiply functions, or divide functions, right? So we're going to get two functions. So let's say we have f of x, and that's going to equal 2x minus 1. And we know because our exponent's 1, if we were to graph this, we would get a line, because it's part of the linear family. And then let's say we have another function, g of x, and let's say that one is x squared plus x minus 2. And we know that one because our highest degree is 2. We know that it's going to be a quadratic, so it's going to be a U-shaped. It's going to open up. We know all those good things, right? So we just want to go through algebraically and be able to combine these two guys together. So we can start by adding these. So the way they'll write it is it'll be f plus g of x. So if we wanted to break that down, that is just f of x plus g of x. So then you're just going to substitute in f of x, and we know f of x is 2x minus 1. So we would have 2x minus 1 plus, because we're adding these two together. And what are we going to add onto it? G of x, and g of x was our quadratic. So we're going to add x squared plus x minus 2. And then what do you think you're going to do? Just going to combine like terms, right? So I just like to keep it in that standard form from like highest degree to lowest degree. Does it have to be in that order? No, but it just kind of makes it nice and clean. So when it comes to all of us comparing our answers, right? So what would I have? X squared, that's too close. I have x squared plus 3x minus 3. If I did the old algebra right. Not too shabs. Right. So if we know how to add functions together, we should probably try and do what? Subtract them. Right. So let's say they gave us f minus g of x. So that would be f of x minus the function g of x, right? Substitute in your f of x. That would be 2x minus 1 minus your g of x. When I subtract, I throw that guy in parentheses. So I'm going to subtract that whole entire function, right, of x squared minus x minus 2. I'm not just subtracting the x squared, I got to subtract the whole entire thing. So I got to make sure that I'm distributing that negative through everything, right? So then I'd have what? 2x minus 1 minus x squared plus x plus 2. And then if we combine our like terms, we get what? Negative x squared Whoops, I wrote my function down wrong, didn't I? I apologize. Ooh, can I make it small? Because our function is x squared plus x, I put a minus x. So this one should be a positive, right? And then that one should be a negative. So I get plus x plus 1. Did you guys catch my boo-boo when I made it? You can yell at me and tell me, right? Mistakes are fine. All right, we good with adding and subtracting? So we might as well move on to some multiplication. So for C, they'll write it as f of g of x. So that's just f of x times g of x. Right? Do a little substitution. What was our f of x? 2x minus 1 times g of x, x squared plus x minus 2. So you guys have a couple options on these. When you're multiplying polynomials, you can use that distributive property, right? Because you got to make sure you share with everybody. So you can do 2x times x squared, 2x times x, and 2x minus 2. Okay. But then you got to do it with the negative 1, right? Negative 1 times x squared, negative 1 times x, and negative 1 times 2. Or the other option is making a area model, right? Making the box. And if you make the box, you know you don't accidentally skip anything, right? So we have 2 terms and 3 terms. So our box needs to be a 2 by 3. So we have what, 2x minus 1 for our 2 terms, and then our 3 terms would be x squared plus x minus 2. So what are we going to get? 2x to the third, 2x squared minus 4x. Oops. Negative x squared, negative x plus 2. Did you guys get the same thing I ended up getting? And then we just got to combine like terms. And usually, if your original polynomials go from like highest degree to lowest degree, usually for the most time, if you look at the angles or on the diagonal, those will be your like terms, right? So what do we end up getting? 2x to the third. I think we only have 1x squared. We got negative 5x's plus 2. My glasses are fogging up today. I think I got them. So really all the math behind all of this is we've been used to doing these. We've multiplied functions, we've added functions, or even dividing functions, which is next. So really the only new piece is kind of when it comes to this notation, right? It's just how they denote when you're doing it with functions. All right, whoop. Add, subtract, multiply. Last one is dividing. So you guessed it, f divided by g of x, right? So that's just going to be f of x divided by g of x. So our f of x was 2x minus 1. Right? And our g of x was, what was it, x squared plus x minus 2. And you guys remember how to divide fractions, or divide functions, or divide polynomials, right? We want to be able to see if we can simplify this. So we're going to factor. And on top, we can't do anything factor-wise, right? 2x minus 1 is going to stay that way. So on the bottom, because we got a quadratic, we're going to look for those two factors. To get x squared, we know we got x and x. A times c is negative 2. So to get a negative, you got to multiply a positive and a negative together. You're multiplying to get negative 2 with the difference of positive 1. So we're going to have, what, a positive 2 and a negative 1. Right. And we can't cancel anything out, but then we also know that we got some restrictions on this, right? Because our denominator can never equal 0. So we know that x cannot equal negative 2, and x cannot equal 1. Should have thrown one in there that we could cancel or simplify. All right. So we good with adding, subtracting, multiplying, and dividing? Nice little review-ish. All right. So the new part are these things called composite functions. So on a composite function, you're taking like the answer of one function, and then you're using that answer to figure out the answer to another function. So how many of you guys have ever gone to the store and something like you find a cool shirt and the shirt's on sale, but then the store's having like an additional sale? So the shirt was 30% off, but for today only, we're taking an additional 20% off of everything. So you're like, wow, that's really cool. It was 30% off, and now it's an additional 20% off, so it's going to be 50% off, right? No, right? It's you get 30% off of that price, and then you only get 20% off of the sale price. So it doesn't actually end up being 50% off. It's less than that, right? So that's what these composite functions are, is you're figuring out the one part of the function, and then you're plugging that in for the second function. So it's kind of a funny notation. You have f, which is your function, and then it's like a, think of like if you were to put a dot for like a multiplication, but you know, you were a cool bubble letter writer, and you just put a little circle. So it almost looks like fog, right? But that O is just like a little O. I probably could even make it a little smaller for you guys. Right. So ultimately, what this is your F is you have to put in your answer from g of x. So you're figuring out whatever g of x is, and then whatever you get for that answer, you're then plugging that in for f. Okay. So the first thing we're going to do is we're going to input x into g. Then we're going to get an output, and that's technically your g of x, right? That's your output. And then we're going to take that output and make it an input. So then you're going to input whatever you get for g of x. And you're going to put that into f, the function of f. And then you're going to get an output. And your output for f was when you put in g of x. You're like, what does that mean? Too many inputs, too many outputs, right? So we might as well do an example, huh? All right, so we're going to have two functions, or who knows, they might give you more than two. You can do these composites with as many functions as they want to give you, but we're just going to stick with two. So let's say we have f of x, and that's going to equal, let's go with 3x minus 4. And then we have a g of x, and we'll go x squared minus 2x plus 6. And they're going to give us f of g, and they're going to have us start at 1. Okay. So this is telling us, in order to get f, we need to first find g of 1. Okay. So if we go all the way into the inside, that g of 1, I need some pages. There you go. So we need to evaluate our function g at 1. So we're just going to go through our function of g, and what are we going to put in for our x's? We're going to put in that 1, right? So I'm just going to carry my f down so I don't lose the guy. Okay. And then let's see if we can put 1 in, right? So 1 squared is going to give us 1. If we put in 1, negative 2 times 1 is negative 2. And then we still have our plus 6. Okay. I'm just going to bring down my f so I don't lose them. So 1 minus 2 plus 6 is that 5? Okay. So then now what am I going to do with this 5? I'm going to evaluate my f function, right? So I'm going to put 5 in for my x. And then what am I going to get? I'm going to get 3 times 5 is 15 minus 4. So I'm going to get 11. I wonder if we'd get the same answer if we flip this around. So instead of doing f of g, I wonder if we flipped it around and we did, whoops, g of f at 1. So this is telling us in order to find out what our answer for g is, we need to first start with evaluating f at 1. Okay. So I'm going to bring my g down just so I don't lose him, right? He's a good guy, that g. And then I need to evaluate my function f at 1. So I'm going to put 1 in, right? So that's going to give me g of 3 times 1 is 3 minus 4. 3 minus 4 is negative 1. So now I need to evaluate my g function for a value of negative 1. So I'm going to negative 1 squared minus 2 times negative 1 plus 6. If we need to write it all out. Okay. Negative 1 squared is 1. Right? Negative 2 times negative 1 is going to give me a positive 2 plus 6. So I'm going to get 9. So when it comes to doing these composite functions, we got to make sure that we pay attention to the order, right? Because depending on which order we evaluate these, they're going to get two different answers.